Welcome to 11.3, Systems of Linear Equations Continued. Now we're going to talk about something called the determinant. We're going to evaluate 2 by 2 determinants, use something called Cramer's rule to solve the system of 2 and 3 equations with 2 and 3 variables, evaluate 3 by 3 determinants, and then you, after reading your text, should know the properties of determinants. We'll talk about a few of them here, but it's really important for you to go through those theorems yourself and fill out your note sheet. So, finding the value of these determinants. We'll start with 2 by 2's. Following our determinants, we do 2 times 3 minus -3 times 8, which gives us 6 plus 24, which is 30. Not too terrible. Not at all. Next we have -3 times 2 minus 6 times -5, which is -6 plus 30, giving us 24. Now, the more tricky determinants are 3 by 3's. Anything above a 2 by 2 gets a little bit tricky, but we can still use a process here. What I do is I choose one row or column, so you can choose one. I'm going to choose this row because it has a lot of ones in it, so it's going to make my calculations very simple. And then you take the coefficient, so 4 is the first one, and then what I'm going to do is I'm only going to focus on what's left. So I have the determinant of -4, 1, 3, 4. And then I subtract, and I do the next one. So next is 1. So I'm only going to focus on what's not the row and column of that 1. So I have the determinant of 1 times 3, -5, 3, 4. And then I add, and I do the last one. So 1 times the determinant of 3, -5, -4, 1. And then we calculate these determinants. So 4 times -4 times 4 minus 1 times 3 minus 3 times 4 minus -5 times 3 and plus 3 times 1 minus -5 times -4, which would give us 4 times 16 minus 3 minus 12 plus 15 plus 3 minus 20, 4 times that's a -16, so -19 minus 27 plus -17. This gives us -120. And let's do that process again. So I'm going to choose this row. So I'm going to do 3 times the determinant of -2, 4, 3, 3, minus 2, -2, 3, 3, plus 2, -2, -2, 4. And now we find each of these determinants. 3 times -6 minus 12 minus 6 plus 6 plus 8 minus 4. That will give us 3 times -18 minus 12 plus 4. That is -62. Now let's solve using Cramer's rule. Now Cramer's rule uses the determinants, and it allows us to solve for each variable individually. So for x, we're going to use the determinant of our solution column and then the y column. So we're placing the solutions in as x, and then the y column. On the bottom, we're just placing our x and y columns. So determinant of 1, 1, 1, -1. This gives us -8 minus 2 over -1 minus 1, which is -10 over -2, which is 5. So for x, we have 5. For y, we'll do the same thing. So we'll put our x's, determinant of our x column, and then in the y column, we'll put the solution over the x's and y's. This gives us -2 minus 8 over, we already solved that for -2, -6 over -2. That gives us a 3. So x equals 5, y equals 3. Okay, now we have x equals, in the x column, we'll put 4, 35, y column, -1, 4, over the determinant of our x's and y's. So determinant of 3, -1, 5, 4, 16 plus 35 over 12 plus 5. This gives us 51 over 17, which is a nice 3. Our y, we'll do 3 and 5 for our x's, 4, 35 for our solutions, and then the bottom is going to be the same, 17, because we're using the same bottom. So we have 105 minus 20 over 17, which is 85 over 17, which gives us a nice 5. So we have x equals 3, y equals 5. Okay, now let's use Cramer's rule for 3 by 3s. So we'll do x equals, and the same thing, we're going to replace the x with the solution, -6, 5, -24. We're going to put our y's, 1, -1, 5, and our z's, -1, 4, -3, over the determinant of our x, y, and z values. So 1, 3, 1, 1, -1, 5, -1, 4, 3, -3. This gives us -6 times the determinant, -1, 4, 5, -3, minus 1 times the determinant of 5, 4, -24, -3, minus 1 times 5, -1, -24, and 5, over 1 times -1, 4, 5, negative 3, minus 1 times 3, 4, 1, negative 3, minus 1 times 3, negative 1, 1, 5. This will give us negative 6 times 3 minus 20 minus negative 15 plus 96 minus 25 minus 24 over 3 minus 20 minus negative 9 minus 4 minus 15 plus 1. And this gives us 20 over negative 20, which is a negative 1. Next, we'll find our y value. I'll put it over here. I'll put it right here. Y. So the bottom we know is negative 20. The top is going to be determinant of 1, negative 6, negative 1, 3, 5, 4, 1, negative 24, negative 3. This gives us the determinant of 1 times 5, 4, negative 24, negative 3, minus 3 times the determinant of negative 6, negative 1, negative 24, negative 3, plus 1 times the determinant of negative 6, negative 1, 5, and 4. It's all over negative 20. That gives us negative 15 plus 96 minus 3 times 18 minus 24 plus negative 24 plus 5 over negative 20, which gives us 80 over negative 20, which is negative 4. And now we can do our z value. I'm going to do it in a different color, that way it doesn't get confused with other stuff. So z is determinant 1, 1, negative 6, 3, negative 1, 5, 1, 5, negative 24 over the negative 20. This will give us determinant negative 1, 5, 5, negative 24, minus the determinant of 3, 5, 1, negative 24, minus 6 times the determinant of 3, negative 1, 1, 5, all over negative 20. This gives us negative 1, 24 minus 25 minus negative 72 minus 5 minus 6 times 15 plus 1 over negative 20. This gives us negative 20 over negative 20, which is 1. So our solution, x equals negative 1, y equals negative 4, z equals 1. And one more using Cramer's rule. So for x, we'll have determinant 5, 5, 1, negative 1, 1, negative 5, 1, 1, 5, negative 5, over the determinant 1, 5, negative 1, 2, negative 5, 1, negative 3, 5, negative 5. So this will give us 5 times the determinant, negative 5, 1, 5, negative 5, minus determinant of 5, negative 1, 5, negative 5, plus the determinant of 5, negative 1, negative 5, 1, over the determinant of negative 5, 1, 5, negative 5, minus 5 times the determinant of 2, 1, negative 3, negative 5, minus the determinant of 2, negative 5, negative 3, 5. This will give us 5 times 25 minus 5 minus negative 25 plus 5 plus 5 minus 5 over 25 minus 5 minus 5 times negative 10 plus 3 minus 10 minus 15, which is going to be 120 over 60, which is 2. Now for the y, let's do a different color. We have the determinant of 1, 5, negative 1, 2, 1, 1, negative 3, 1, negative 5, over 60. This will give us the determinant of 1, 1, 1, negative 5, minus 5 times the determinant of 2, 1, negative 3, negative 5, minus the determinant of 2, 1, negative 3, 1, over 60, which is negative 5 minus 1, minus 5, negative 10 plus 3, minus 2 plus 3, over 60, which gives us 4 over 10, which is 2/5. And finally, for z, we get the determinant 1, 5, 5, 2, negative 5, 1, negative 3, 5, 1, over 60, which is 5 times the determinant of 2, negative 5, negative 3, 5, minus 1, 5, negative 3, 5, plus determinant of 1, 5, 2, negative 5, over 60. This gives us 5 times 10 minus 15, minus 5 plus 15, plus negative 5 minus 10, over 60, which gives us negative 60 over 60, which is negative 1. So we have x equals 2, y equals 2/5, z equals negative 1. Okay, let's solve for x using these determinants. So, using our determinant, we know we have x times 4, so 4x minus negative 4x equals negative 48. So 4x plus 4x equals negative 48. 8x equals negative 48. X equals negative 6. Here's another one. We've done these 100 times already, so we are good to go. X times the determinant of 3, 1, 3, 5 minus the determinant of 2, 1, negative 1, 5 plus the determinant of 2, 3, negative 1, 3 equals negative 5. X times 15 minus 3 minus 10 plus 1 plus 6 plus 3 equals negative 5. 12x minus 11 plus 9 equals negative 5. 12x minus 2 equals negative 5. 12x equals negative 3. X equals negative 1/4. Okay, now this one is an interesting one. Find the value of the determinant of xyz negative 454 UVW if it is known that the determinant of negative 454 xyz UVW equals 6. What happened from this one to this one? We can see that the row was switched here. Row 1 and row 2 got switched. You see that? When we look through the theorems on determinants, those are very important. I suggest going through those, adding them to your notes, making sure that you understand what happens when we change the determinants. In this case, when we switch a row, the value of our determinant becomes negative. So we have theorem 12 is where we see this. Our value, knowing that just a row got switched, our value is negative 6, thanks to our theorem.